Hello everyone, I am Balaji Rao. Welcome to BR Max class. Till now, we completed 6 exercises in sets chapter. Now, we are going to start miscellaneous exercise. Compared to first 6 exercise problems, miscellaneous exercise problems are little difficult. Especially first 10 problems, you may feel difficulty. So, what my suggestion is, first you make sure you are good in first 6 exercises or not. Once you are good in first 6 exercises, then you are ready to learn miscellaneous exercise problems. In case if you are not good in third exercise or fourth exercise of sets chapter, then definitely you will feel a very confusion part in miscellaneous exercise problems. So what I am trying to say, before starting miscellaneous exercise, please make sure that you are good in all the definitions and all the formulas and you practiced all exercise problems thoroughly. Once you are perfect in all exercise problems, then it means that you are ready to do miscellaneous exercise problems. I tried my best to simplify complicated things in easy way. Without much delay, let's begin the class. Miscellaneous exercise on chapter 1. In this miscellaneous exercise, total 16 problems are there. These are little difficult problems compared to exercise problems. In sets chapter, total 6 exercises will end. Up to exercise number 1.6 will end. If you are good in first 6 exercises, then you can do this miscellaneous exercise problems very easily. Okay, however, let's see the solution for first question. You observe what is the first question. Decide among the following sets. They given some sets here A, B, C, D. Among the following sets, which sets are subsets of one and another? If you know the definition of subset, then you can do this problem very easily. What is the definition of subset? When we say two sets are subset to each other, when we say A is subset of B, if all the elements present in set A are present in set B, then set A is called subset of B. For example, if I take A equal to 1, 2 and if I take B equal to 1, 2, 3, 4, 5. Now you observe all the elements present in set A are present in set B. You see 1, 2 are present in A. 1, 2 are present in B also. All the elements present in set A are present in set B. So, in this example, A is subset of B. At the same time, is B is subset of A? When we say B is subset of A, all the elements present in B are present in A, then we call B is subset of A. But actually, in this set B, 3 is there. 3 is not in set A. So, in this example, B is not a subset of A. In this example, A is a subset of B, but B is not a subset of A. Okay. If you observe here sets, first set is given in set builder form. What I'll do, I'll write this set in roster form. Roster form means what? All the elements are listed and separated by commas within the brackets. If I write this set in roster form, I can easily compare this set is subset to each other or not. Okay, so what I'll do here, first I'll write set A in roster form. What is set A? They given like this. Set A is X such that X is a real number and satisfying this equation. Okay. So what I'll do here, what is the equation they given? X square minus 8x plus 12 equal to 0 they given. I'll split the middle term. Minus 8x is there, na? That can be written as minus 2x minus 6x plus 12 equal to 0. Now in these first two terms, you take x common, then what you will get? You will get x into x minus 2 minus, in these two terms, you take minus 6 common, then what you will get? You will get x minus 2 equal to 0. Now, in this term x minus 2 is there, in this term also x minus 2 is there. You take x minus 2 common, then what you will get? X minus 2 into x minus 6 equal to 0. Okay, now what I can write here? I can write that x equal to 2 or x equal to 6, right? Product of two terms is 0 means either x minus 2 equal to 0 or x minus 6 equal to 0. That means x equal to 2 or x equal to 6. So these are the real numbers satisfying this equation. So what is set A? Set A in roster form. Set A is 2, 6. Now I'll write other given sets also. What is set B? Set B is 2, 4, 6. What is set C? Set C is 2, 4, 6, 8 and so on. Set D is given as singleton set 6. These are the 4 sets they given in the question. Now what you need to check? Which sets are subsets of one and another? I need to check. How I'll check? First I'll take set A. I'll check that A is subset of B or not. I'll check that A is subset of C or not. I'll check that A is subset of D or not. Later, same procedure I'll follow for set B also. First, let's take set A and you check that A is subset of B or not. I'm taking set A and I'm checking that A is subset of B or not. You check, is A is subset of B? All the elements present in A are present in B? Yes. In this set A 2, 6 are there. In this set B also 2, 6 are there. So here clearly A is subset of B. Okay, this is the one point. Now you observe set A and set C. A is subset of C. All the elements present in A are present in C. You observe here 2, 6 present in set A, 2, 6 present in set C also. So what I can write here? I can write that A is subset of C. Okay. Now is A is subset of D? Is A is subset of D? All the elements present in A are present in D. Actually 2 is present in set A but 2 is not in set D. So A is not a subset of D. I am not writing here A is not a subset of D because they are asking which set is subset to one another, like that they asked. Okay. With set A I verified with all the sets. Now I'll take set B. Now I'll check that B is subset of A or not. B is subset of C or not. B is subset of D or not. Okay. Now take set B. Now is B is subset of A? All the elements present in B are present in A. Actually in set B element 4 is there but 4 is not in set A. So here clearly B is not a subset of A. Okay. Now you check that is B is subset of C. All the elements present in B are present in C. Yes. 2, 4, 6 are there in set C. So clearly here B is a subset of set C. B is a subset of set C. Okay. Now check that is B is a subset of set D. No. Actually in set B the element 2 is there but the 2 is not in set D. So here what I can say? I can say that B is not a subset of D. B is not a subset of D. But I don't want to write this not a subsets. Which one is subset to one another? That is the question. Okay. I taken set B and I checked with all other sets. Now I'll take set C. Now you check that set C is a subset of A. All the elements present in C are present in A. No. Actually 4 is present in C but 4 is not in A. So C is not subset of A. Now you check that is C is subset of set B. Actually 8 is there in set C which is not in set B. Here C is not a subset of B. Now you check that set C is a subset of D. No. Actually 2 is there in set C that is not in set D. So C is not a subset of D. Now here interesting factor. Now we will take set D. Okay. Set D. Now what I need to check? I need to check D is subset of A or not, D is subset of B or not, D is subset of C or not. Okay, you check here, D is subset of A. Is D is subset of A? All the elements present in set D are present in A. Yes, set D contains 6. 6 is there in set A. So what I can write here? I can write that D is subset of A. Now, D is subset of B. Yes, in set D only one element is there, 6. All the elements present in D are present in B. All the elements present in D are present in B. So what I can say here? I can say that D is subset of B. Now, is D is subset of C? All the elements present in D are present in C. Yes, the 6 is present in D, 6 is present in C. So here D is subset of C. So what they are asking in the question, which sets are subsets of one another? Here you can see A is subset of B, A is subset of C, B is subset of C, D is subset of A, D is subset of B, D is subset of C. So whatever the given 4 sets are there, in that these sets are subsets of one another. I hope you understand this first problem. Now we'll move to next question. You observe the second question, what they are asking. In each of the following, they given total 6 bits here. In each of the following, determine whether the statement is true or false. You need to decide the statement is true or false. If it is true, then prove it. Okay. If it is false, give an example why it is false. Okay. So first let me take the first bit in this and we'll try to understand whether the statement is true or false. The point is we need to identify whether this is true or false. If it is true, if this is true, we need to prove it. If it is false, we need to give an example, like counter example. Here this is little difficult to understand for students, but actually what they given, they declared one statement here. Whenever X is there in set A and A belongs to set B, then X is also belongs to B. They declared one sentence here. Whenever these two things holds good. If X belongs to A and A belongs to B, then X belongs to B, they are saying. So what I'll do, I'll check this with random example. I'll take set A equal to 1, 2. Okay. And set B, I'll consider in such a way that this set A is present in set B. Actually, this problem you can understand in exercise number 1.3, third problem is there. In sets exercise number 1.3, third problem is there. If you understand that problem, this can be understood very easily. Okay, here I am considering set B in such a way that A is belongs to B. Set B, I'll write like this, 1, 2, 3. I written like this. Now you observe this, if I take X in set A belongs to B. Right? Then X belongs to B they given. Here you observe I considered set A and you observe set B. I consider in such a way that this is set A, correct? This is set A. A is in B. This set A is in B. Okay. Now I consider a statement by using these 2 points. Now I'll take one element X in A. I'll take one element X in A. Now I'll check that element X is there in B or not. Before that, you need to know how many elements present in set B. You know that all the elements of a set in roster method are listed and separated by commas. In set B, total 2 elements are there. This is one element, this is another element. Total 2 elements are there. Now my question is, in this set 1 is there? In set B, 1 is there? No, 1 is not there. 1 does not belongs to set B. If you know that knowledge, then you can understand this problem. Otherwise, you cannot understand. 2 is there in set B. No, 2 does not belongs to set B. 3 is there in set B. Yes, 3 is present in set B. Here, how many elements are there in set B? 2 elements are there. This is A. Okay, set A. Okay, and this is element 3. Only these 2 elements present in set B. Now, here You observe, you take one element in set A. Suppose 1 is there in set A. 1 is there in set A. I taken x belongs to A, they are saying now. So I taken 1 from set A. Now, is this 1 is there in set B? You check here. 1 is there in set B. 1 does not belongs to set B. So what happened here? They declared this statement. But what happening as per this, if x belongs to A and A belongs to B, then x belongs to B, they are saying. Here I am checking now. 1 belongs to B and this A is belongs to B, but 1 is not in set B. 1 is not in set B. Observe, in set B, two elements are there, this and this. 1 is not there in set B. So clearly we can say that this statement is false. I hope you understand. If you have good knowledge of subset and what elements present in the set, you exercise number 1.3 third problem you practice. If you are good in that problem, then you can understand these problems. In case if you confuse, please go back and try to observe from the beginning onwards what I am saying in this solution. Definitely you will get the solution. You can understand it. Okay, now we will move to second bit. You observe this second bit. What they given? A is subset of B, B belongs to C, then A belongs to C. They given one statement here. 3 sets are there. A, B, C, 3 sets are there. Okay, I will take like this example, counter example. I am trying to check with the example. A is 1, 2. Okay. B is what? A is subset of B they given. I will take like this. B as 1, 2, 3. Okay. A is subset of B. I consider B in such a way that all the elements present in A are present in B. Okay. And they are saying that B belongs to C. I will consider set C in such a way that set B is there in this. What I will write here for set B, like this is set B. You observe here, in set C how many elements are there? In set C 2 elements are there. One is the element 4, another one is set B. B belongs to C. Please try to understand. B belongs to C. The same set C you can write like this. C is 4 comma. What is this set? This set is nothing but B. I can write like this. You can observe here. B belongs to set C. B belongs to set C. A is subset of B and B belongs to C. I considered 3 sets satisfying these two conditions. Now I need to check that is A belongs to C or not. A belongs to C or not. This A is there in C. Clearly the set A is not in C. When we say A is in set C, suppose set C is like this. Suppose I am saying, suppose set C is like this. 4 comma B comma 1 comma 2. If it is like this, then we say that A is in set C. But you see here, I got C like this. I taken one example like this. They are saying this is true for any 3 sets ABC. They are saying that this is true for any 3 sets ABC. To say it is false, one example is enough. Here I can create an example which satisfying this condition. I can create an example which satisfying this condition. But that is not, statement means what? This statement means what? It is true for any 3 sets. To say this statement is false, it is enough to give one example. You are saying one statement, man. To contradict it, I can give one example. Right? You may give so many examples that your statement is true. But I can contradict you by giving one counter example. This example, because of this example, your statement is false. Try to understand. Here, they passed one statement here. This statement may be true for some examples, but this is not true for all the sets ABC. That is what I am trying to say. Here, if I take ABC sets like this, with satisfying these two conditions, you check that is A is there in set C? A is there in set C? No, A is not in set C. So what is this? This is false. I hope you understand. You observe this third bit. A is subset of B, B is subset of C, then A is subset of C. Actually, this statement is true. This statement is true. When I am saying this statement is true, you cannot give an example such that this is false. So, in the question only they are saying that when the statement is true, you need to prove it. Okay. Here, I need to prove it. For that, first what I'll do, I'll take A is subset of B, A is subset of B and B is subset of C. Now what I need to prove? I need to prove that A is subset of C. How to prove A is subset of C? If all the elements present in set A are present in set C, then I can say that A is subset of C. What I'll do to prove this, I'll take randomly one element X in set A. I don't know what is X, but I'll suppose that X is there in set A. In the process, by using these two things, in the process, I'll prove that X is there in set C also. It indicates that all the elements present in set A are present in set C. So I can say that A is subset of C. Okay. So here what I'll do, I need to prove A is subset of C na. So what I'll do, let X in set A. You consider X in set A. From this, I can say that X belongs to B also. How can you say like that? Because I have this one, A is subset of B. A is subset of B means what? All the elements present in set A are present in set B. If I take X in set A as A is subset of B, definitely the element X present in B. Okay. Now you got X is in B. As I know B is subset of C, as I know B is subset of C, I can easily say that X belongs to C. Since, why? B is subset of C. B is subset of C means what? All the elements present in B are present in C. Okay. So here X is there in B means X definitely belongs to C. So what happened here? If I take X in set A, definitely X belongs to set C. So what is the conclusion here? Therefore, if X belongs to A implies, therefore what I proved, X belongs to A implies X belongs to C. So from this we can say that all the elements present in A are present in C. Therefore I can say that A is subset of C. Now this is true or false? Yes, this statement is true. I'll write here, this statement is true. And to understand this more clearly, I can give an example, but I cannot give this problem in example method, as I need to prove like this only. A is subset of B, they are saying na. I'll take set A is like this, 1, 2. A is subset of B, they given. Look here, A is subset of B, they given. I'll construct B in such a way that A is subset of B. And you see here B is subset of C, they given. I'll take C in such a way that B is subset of C. All the elements present in B are present in C. Now you look here, A is subset of B. All the elements present in A are present in B. And you look here, B is subset of C. All the elements present in B are present in C. Now you look that A is subset of C or not. Obviously. But with this example, I cannot say that this is true. When it is true, you need to prove it. When it is false, then give the counter example. I hope you understand. You observe this fourth bit. When A is not a subset of B and B is not a subset of C. When these two things are happening, then they are saying that A is not a subset of C. They declared one sentence here. When these two are happening, then this is happening. So they declared here. When I need to give one example if it is false. If it is false, one example is enough, right? If it is true, I need to prove it. Okay, I'll take an example to say this is false. Okay, I'll take set A like this, 1, 2. Okay, you observe here A is not a subset of B. I'll take set B like this. Set B is 3, 4. You can observe here A is not a subset of B. Okay, and they given that B is not a subset of C. Okay, B is not a subset of C. Okay, I'll take C like this. C is 1, 2 and 3. I'll take like this. You can observe, is B is subset of C or not a subset of C? B is not a subset of C. All the elements present in B are present in C. You can see here 4 is present in B but 4 is not in C. So I considered 3 sets A, B, C in such a way that A is not a subset of B and B is not a subset of C. I hope you are understanding. A is not a subset of B and B is not a subset of C. Now in this they are saying that A is not a subset of C, but you see here A is subset of C. All the elements present in A are present in C. I hope you are understanding. What it concludes, what they given one statement, I given one example that this is not true. That means this is false. In the question only they are saying that if it is false, give one example. In this example, you can observe that A is not a subset of B. Okay, and B is not a subset of C. Then they given A is subset of C, but in this example A is subset of C in this example. That's why the given statement is false. Now we'll move to fifth bit. You observe this fifth bit. X belongs to A and A is not a subset of B, then X belongs to B. They given like this. Okay, so I need to prove that this statement is I need to check that this statement is true or false. I'll go with some counter example. I'll take set A as 1, 2. Randomly I'm picking these things. A is not a subset of B, they given. I'll take set B is like this 3, 4. I'll take like this. You observe I taken two sets in such a way that it satisfies these conditions. Here X belongs to A means one element is there. A is not a subset of B. Main thing is this one. A is not a subset of B. You can observe A is not a subset of B. If X is there in A and these two conditions holds good, then X belongs to B, they are saying. You take one element from set A. Suppose I will take 1. 1 is there in set A. And you can see here A is not a subset of B. That means this condition holds good. Now is 1 is there in B? You check it. Check it. 1 is there in B, as A is not a subset of B. Since A is not a subset of B, 1 is there in set B. 1 is not there in set B. What happened here? X does not belongs to B we got. As per this, if I try to take an example, I found one example such that 1 does not belongs to B, right? This is false. I am saying once again, you can create an example which satisfying this condition. You can create one example, but this is the statement. They are saying that this is true for any sets ABC which satisfying this condition. No, see, very simple thing, man. If a student, here I'll tell you one example, please have patience and try to understand. For a student, there are 4 subjects are there: Maths, Physics, Chemistry, Biology. If student got 100 marks in Maths, can you decide that he passed all other exams? Because in Maths 100 he got? No. Suppose in Physics he got 90. Can we declare that he passed all the exams? Can you declare that he passed all the exams? No, you cannot declare. Suppose in Chemistry he got 80. Can you declare that he passed all the exams? We cannot declare without knowing biology marks. I hope you are understanding. He may absent for the biology exam even though he scored well. Maybe he may get 10 marks here. What I am trying to say, when it is true, without checking all the subjects, you cannot decide whether the statement is true or not. But at the same time, in Maths, that fellow got 0. In Maths, if that person got 0, that means we can declare that he failed in that particular exam because he need to pass all the subjects to complete the course. I hope I given some clear explanation here. What I am trying to say, when it is false, one small counter example is enough. When it is true, you cannot prove it with an example. Okay, so right. So this statement is false. Now we'll move to sixth bit. You observe the sixth bit. A is subset of B. X does not belongs to B. Then X does not belongs to A. Actually, this statement is true. When it is true, proving this is little complicated. I cannot give an example. I need to prove this. Okay. To prove this, what I'll do first, let A is subset of B and X does not belongs to B. I am considering these two things. A is subset of B and X does not belongs to B. Now I need to prove that X does not belongs to B also. How to prove this? Okay. How to prove this? Actually, this is a clear statement. How I can explain this to you? Here, to explain this, I am giving an example. I am not proving this. This is an example to explain this. A is subset of B, they are saying. Na? So I'll take an example like this. Set A is 1, 2. Set B is 1, 2, 3. You can observe here A is subset of B. All the elements present in A are present in set B. If one element does not belongs to B, it does not belongs to A. 100% guarantee. You take one element which is not in set B. Suppose 4. 4 is not in set B. 100% 4 is not in set A also. 100%. This is a clear statement. This is a clear statement. When these two things are happening, then we can say that clearly X does not belongs to B. That much only I can say. To make you understand this, I can give one example here. Proof means this is the proof. I hope you are understanding. This is the proof. This is a clear statement. To understand it is clear or not, you take one example and you check it. You take one element which is not in B. You take 5. 5 is not in set B. Now you observe that 5 is not in set A also. Hence the given statement is true. This second question is little difficult to understand, but I tried to give my best explanation. In case if you didn't understand any particular bit, you go there and try to listen that again and again. Definitely I tried to give a complete explanation for that. Still, in case if you have any doubt, you please give comment in chat section so that I'll answer to your question. You observe this third question. A, B, C, B, 3 sets such that A union B equal to A union C and A intersection B equal to A intersection C. Then show that B equal to C. A, B, C, B 3 sets such that A union B equal to A union C, A intersection B equal to A intersection C, then show that B equal to C. Here we need to prove that B equal to C by using these two conditions. Okay. Here B equal to C means two sets are equal. When we say two sets are equal, suppose the set B is a subset of C and the set C is subset of B. In this case, both the cases holds good. Then only we say that the sets B and C are equal. I hope you understand. So here to prove the sets, these two sets are equal, B equal to C. First, I need to prove that B is subset of C. Next, I need to prove that C is subset of B. Okay. So let's start the solution. Before starting the solution, first you write the given data. What they given? They given that A union B equal to A union C and they given, you try to understand, that means both must holds good, then only this works. A intersection B equal to A intersection C. We need to prove that B equal to C. Okay. I said now to prove this, I'll do this in two cases. First, I'll prove that B is subset of C. When B is subset of C and C is also subset of B, then I can say that these two sets are equal. How to prove that B is subset of C? Very simple. I'll take one random element X in set B. I'll take an element X in set B. By using these two datas, I'll prove that X is there in set C also. So if all the elements present in set B are present in set C, then I can say that B is subset of C. So what is the procedure to prove that B is a subset of C? I'll take X belongs to B. Okay, so we started like this. Let X belongs to set B. Okay, if X belongs to set B, can you say that X belongs to A union B? If X belongs to B, then definitely X belongs to A union B. This we learn in operations on sets. While learning the definition of union of sets, we learn this. If X belongs to B, then definitely X belongs to A union B. Okay? Okay. X belongs to A union B. If X belongs to B, then X belongs to A union B. Okay. And we know that they given here A union B is same as A union C. So what I can write here, X belongs to A union C, I can write, since they given that A union B is same as A union C. Okay, X belongs to A union C. X belongs to A union C means what? X is in set A or X is in set C? Here two chances are there. X is there in set A or X is there in set C, or X may present in both also. Basic thing is X belongs to A or X belongs to C. When X belongs to A intersection C, X may be in set A, X may be in set C. Listen carefully. If X is in set C, this problem is over. I am trying to prove B is subset of C now. If X belongs to B, when I got that X belongs to C, I can say that B is subset of C. If X belongs to C, directly I can say that B is subset of C, because for X belongs to B, X belongs to C. For X belongs to B implies X belongs to C, then I can say that B is subset of C. Okay. So here only the problem comes when X belongs to A. Okay. Suppose when X is in A, when X belongs to set A, what happens? Here, as I started with X belongs to B, if X is there in set A, then what I can say? I can say that X belongs to A intersection B. Since we started with X belongs to B, now I am saying that when X belongs to A, X belongs to B. That means when X is there in set A as well as there in set B, then definitely I can say that X belongs to A intersection B. Okay, X belongs to A intersection B. X belongs to A intersection B. You can look here in the given data, they given that A intersection B is same as A intersection C. X belongs to A intersection B is same as A intersection C. So in place of A intersection B, I can write A intersection C. When X belongs to A intersection C, then what I can say? I can say that X belongs to A, and intersection means X will be there in A as well as in C also. X belongs to C. Since because it is intersection, A intersection C means X is there in A intersection C. It means that X must present in A, X must present in C also. I hope you are understanding. So I started with X belongs to B, I ended with X belongs to C. So what is the conclusion I will give here? Therefore, X belongs to B implies X belongs to C. From this, what I can conclude? I can conclude that B is subset of C. I hope you understand this. I proved that. Similarly, if I can prove that C is subset of B, then this problem will be over. Actual thing is what? I am trying to prove that the set B equal to C. I am trying to prove that B equal to C. How to prove? First, I will prove that B is subset of C. Next, I will prove that C is subset of B. Now, this one is over. Now, I need to prove that C is subset of B. Okay. I need to prove that the set C is a subset of B. How to prove this? Very simple. First, I'll take one element in set C. X belongs to C, I'll take. In the process, I'll simplify and I'll get that X belongs to B. If I can prove this, then I can say that C is subset of B. Okay, start with X belongs to B. Let X belongs to C. Start with X belongs to C. I take an X in set C. If X belongs to C, then definitely X belongs to A union C. Clear? if X belongs to C, then definitely X belongs to A union C. This is clear from operations on sets. If you know how to calculate union of sets, then you can easily understand, right? Okay, X belongs to A union C, and A union C is same as A union B. That is the given data. X belongs to, look here, A union C is same as A union B. In place of A union C, I can write A union B. Okay, in place of A union C, I can write A union B, since A union C is same as A union B. Okay, right. So now X belongs to A union B means what? X belongs to A or X belongs to B, correct? A union B means X may be in set A or X may be in set B. Here you observe, if X is in set B, this problem is over, because I started with X belongs to C and X belongs to B, then I can easily say that C is subset of B. Only the problem arises when X belongs to A. Okay, look here, when X belongs to A, when X belongs to A. When X belongs to A, as I started with X belongs to C, I can easily write that X belongs to A intersection C. X belongs to A as well as X belongs to C. X belongs to A intersection C. So what I can say here, X belongs to A intersection C, and you see A intersection C is same as what they given in the data. A intersection C is same as A intersection B. Look here, A intersection C is same as A intersection B. In place of A intersection C, what I can write? I can write A intersection B, because they given A intersection C is same as A intersection B. Okay, when X is there in A intersection B, X is there in A as well as X is there in B also. From this I can easily say that X belongs to B. Now you observe, I started with X belongs to C, I got that X belongs to B. So I'll write here, therefore, if X belongs to C implies X belongs to B, then what is the conclusion? Then the conclusion is C is subset of B. Here we proved that B is subset of C, you take it as 1. And here we proved that C is subset of B, you take it as 2. From 1 and 2, from 1 and 2, from 1 and 2, what we can say? When B is subset of B and C is subset of B, then I can say that the sets B and C are equal. So here this condition holds good only when this full, look here, this result holds good when A union B equal to A union C as well as A intersection B equal to A intersection C. When both are holds good, then only B equal to C. I hope you understand this third question. Please observe this question number 4. Show that following 4 conditions are equivalent. Here 4 things are given, they are all equivalent. That means when A is subset of B, A minus B equal to empty set. When A is subset of B, A union B equal to B. When A is subset of B, A intersection B equal to A. Actually, all these are if and only if condition. When A minus B equal to pi, then A is subset of B. When A minus B equal to pi, A union B equal to B. When A minus B is phi, A intersection B equal to A. Like that, all these are if and only if conditions. Here I don't want to confuse you by saying that X belongs to A implies X belongs to B, and X belongs to A but X not belongs to B, like that. I just want to do it as simple as possible. I'll explain this with the help of Venn diagram. Okay, so here A, B, 2 sets are there. So I'll take 2 sets A and B. Okay, this is one set. Okay, and I need one more smaller set. Here the basic point is, these are all formulas. I'll say simply like this. When A is subset of B, then A minus B is null set. When A is subset of B, A union B is B. When A is subset of B, A intersection B is A. Main thing of this question is you want to learn this point. When A is subset of B, all these things holds good. When all these things holds good, A is subset of B. Here you observe I taken 2 sets. Here smaller set is set A, bigger set is set B, because they are saying that A is subset of B. What it mean? Whatever the area present in A, whatever the elements present in A, that present in set B also, because B is the bigger set. All the elements of set A are present in set B. This diagram itself indicates that here this set A is subset of B. Okay, so I taken A is subset of B. Now you observe second bit. Here what happened here, first bit is A is subset of B. Okay, when A is subset of B, what I got here? You look here, A minus B. A minus B means what? All the elements present in A but not in B. A minus B means what? All the elements present in A but not in B. You observe, when A is a subset of B, is there any element present in set A which is not in B? Is there any element present in set A which is not in B? When A is subset of A, all the elements of set A are present in set B. I hope you are understanding. Then actually what is A minus B? All the elements present in A but not in B. Okay, so is there any element in set A which is not in B? No, all the elements of set A are in B, as A is subset of B. From this we can say that A minus B equal to null set. I hope you understand this. And when A is subset of B, A union B is B only. It is simple. When we do the union of two sets, look here, A is subset of B. A union B means what? A union B means all the elements present in A are present in B are present in both. Okay, here all the elements which are present in A are present in B, right? So here what I am trying to say, if X is there in A, then definitely X is there in B. When we do union, look here, I just want to say this point. When A is subset of B, A union B is B. When we do the union, you will get bigger set. When you do the intersection, you will get smaller set. When A is subset of B, B is the bigger set, A is the smaller set. So here this is very, very important. When A is subset of B, what you can say? A union B equal to B. How to prove this? With the help of Venn diagram. I'll write here clearly. Second point I'll write like this. When A is subset of B, this implies clearly, I'll write from Venn diagram, clearly from Venn diagram, what I can say? I can say that A union B is B. This is very simple, right? In the same way, when A is subset of B, A intersection B is what? Look here please. See here, when A is subset of B, then what is A intersection B? What is A intersection B? When A is subset of B, look here, A intersection B means the elements which are present in A as well as in both. As A is subset of B, all the elements present in A are present in B also. When we do intersection, this is the zone which is present in A as well as present in B. So A intersection B is A. It's a simple thing, right? So here I just try to prove this with the help of Venn diagram. Every time not necessary taking that X belongs to taking like this, X belongs to A implies X belongs to B, A is subset of, not necessary. Basic idea of this is very simple. Whenever you know A union B equal to B, we can directly say that A is subset of B. Whenever you know A intersection B equal to A, you can say that A is subset of B. When you know A is subset of B, you can write that A minus B equal to empty set. When you know A is subset of B, you can write that A union B equal to B, A intersection B equal to A. These are all equivalent conditions. So with that, from the Venn diagram, we can observe it clearly. In exam also you write like this. From the Venn diagram, it can be observed clearly. No need to prove unnecessary complications. No need to do this problem. Don't make it complicated. Keep it simple. Right. This is the solution for this problem. Observe this question. Show that if A is subset of B, that means when A is subset of B, we need to prove that C minus B is subset of C minus A. So actually you need to prove this result. How to prove one set is subset of another set? Actually what I'll do, I'll take a random element in this set. I'll take x in C minus B. By using this information, I'll prove that x belongs to C minus A. So whenever x belongs to C minus B implies x belongs to C minus A, we will get, at that time I can say that C minus B is subset of C minus A. Okay, first thing, I'll take let x belongs to C minus B. Okay, x belongs to C minus B. What I can say from this, x belongs to C minus B means, A minus B means what? All the elements present in A but not in B, correct? A minus B means what? All the elements present in A but not in B. Here x belongs to C minus B means what? It means that x belongs to C but, or else I'll write and, x belongs to C and x does not belongs to B. Try to understand. Here I taken x belongs to C minus B. From that I got that x belongs to C and x does not belongs to B. Here very important point. As we know that A is subset of B, we need to consider this first. What is the given data? I'll write here given. What they given? They given that A is subset of B. Okay. As A is subset of B and x does not belongs to B, then x definitely does not belongs to A. We did this in a miscellaneous exercise only. Second problem, last bit you see. In miscellaneous exercise, second problem, last bit. When A is subset of B and x does not belongs to B, implies x does not belongs to A also. So here, what I can write here, x belongs to C and x does not belongs to A. Since we know this result, since A is subset of B, since A is subset of B and x does not belongs to B, implies x does not belongs to A. We know that this result is true. We know this result. We proved in second miscellaneous exercise, second question, last bit. So here what I got that x belongs to C and x does not belongs to A. From this what I can say? I can say that x belongs to C minus A. C minus A means what? All the elements present in C but not in A. You see here, x is the element present in C but not in A. So what I got here, when A is subset of B, then C minus B is subset of C minus A. I hope you understand this. I'll conclude here. Therefore, if x belongs to C minus B implies x belongs to C minus A, we got. As you got that x is there in C minus B and x is there in C minus A, what I can conclude here? I can conclude that C minus B is subset of C minus A. I hope you understand this. You observe this sixth question, what they are asking. Assume that when P of A equal to P of B, then show that set A equal to set B. Okay, this is little difficult to explain. So that's why first try to understand what is A, what is P of A. I taken one example here, set A equal to 1, 2. Then what is power set of A? Power set of A is set of all subsets of set A. In this set, how many elements are there? 2 elements are there. Number of subsets of A is what? 2 power number of elements in set A, that is 2 power 2. 4 subsets you will get for set A. Here I written all the subsets of set A. Here you need to understand one point. If 1 belongs to set A, then definitely singleton set 1 belongs to P of A. I hope you understand this. If 1 is there in set A, then definitely singleton set 1 belongs to P of A. Clear or not? Look here. If 2 belongs to A, 2 belongs to set A or not? Yes. If 2 belongs to set A, then singleton set 2 belongs to P of A. Without any doubt, you can observe here. Singleton set 2 belongs to P of A. Okay. So here the point is, first I'll write the given data. What is the given data? Given data is power set of A equal to power set of B. What I want to prove? I want to prove that A is subset of B. When we say two sets are equal, when A is subset of B and B is also subset of A. When these two holds good, then we say that the sets A and B are equal. Okay, first I'll try to prove that A is subset of B. Okay, I am trying to prove that A is subset of B. Okay, how to prove that A is subset of B? Very simple. You take one element X in set A. You simplify. At the end, in case if you got like this, X belongs to B, it tells you that all the elements present in set A are present in set B, then we can say that A is subset of B. Okay, so to prove A is subset of B, first I'll take randomly one element in set A. Let X belongs to set A. If X belongs to set A, then definitely this singleton set X belongs to P of A. I hope you are understanding. You observe here, if 1 is there in set A, singleton set 1 definitely will be there in P of A. Okay, as the given P of A is same as P of B, in place of P of A, I can write P of B. Try to understand. In place of P of A, I can write P of B. Why? Because since in the given question, they given that P of A is same as P of B. Please try to understand here one point very clearly. If singleton set X belongs to P of B, it is 100% clear that X belongs to B. I hope you are understanding. This is the tricky part here. Okay, so what happened here? Therefore, X belongs to A implies X belongs to B. So what I can say? I can say that A is subset of B. You consider it as 1. Similarly, we can prove that B is subset of A. In exam, you can write, similarly we can prove that. But I just want to prove the second one also. B is subset of A. I want to prove that B is subset of A. How to prove B is subset of A? Very simple. I'll take one element X in set B. I'll take one element X in set B and I'll simplify. At the end, if I get that X belongs to A, then I can say that B is subset of A. So, to prove B is subset of A, first I need to take one element in set B. Okay, let X belongs to set B. Okay, I taken X belongs to set B. If X belongs to set B, it is 100% clear that singleton set X definitely belongs to P of B. In the question, they given that P of A is same as P of B. So what I can write here, singleton set X definitely belongs to P of A. Why? Since they given that P of B is same as P of A. So in place of P of B, I written P of A. It is very clear that if singleton set X belongs to P of A, then definitely X belongs to A. So what happened here? Therefore, X belongs to B. I started with X belongs to B. At the end, I got that X belongs to A. From this, what I can say? I can say that B is subset of A. You observe, first one is what? First one is A is subset of B. Second one is what? Second one is B is subset of A. So what I can say here? Therefore, from 1 and 2, from 1 and 2. What you can say? From 1 and 2, we can say that A equal to B. I hope you understand. This is little tricky problem. Only the point you need to understand that if 1 is present in set A, then singleton set 1 definitely belongs to P of A. This is the tricky part. If 2 is present in set B, then singleton set 2 definitely belongs to P of B. I hope you understand this solution. Observe this question number 7. What they are asking. Is it true that for any sets A and B, P of A union P of B, here P of A means power set of A, P of B means power set of B, P of A union P of B equal to P of A union B? Justify your answer. Okay, here I will try to explain this with example. Let any two sets A comma B. I'll take sets like this. Set A is 1 comma 2 and set B is 1 comma 3. I considered two sets like this, A and B. First I'll calculate P of A. You know what is P of A? P of A means power set of A. What is the definition of power set of A? Set of all the subsets of A. Now you need to write all the subsets of set A. Empty set is subset of every set. So I written that. Singleton set 1. You observe that this is subset of A. At the same time, singleton set 2 is also subset of A, and this is also subset of A. I written P of A. Now I'll write P of B. What is P of B? Set of all subsets of set B. I'll write P of B. You observe set B. I'll write all subsets of set B. First, empty set is subset of every set. So I'll write empty set. 1 is there in set B. So singleton set 1 will be there in P of B. And singleton set 3 will be there in P of B. And every set is subset to itself. So the set 1, 3 also will be there in P of B. Now I'll write P of A union P of B. Okay. So P of A union P of B. First I'll write all these elements. Empty set and singleton set 1. Singleton set 2 and the set 1, 2. Now you write all the elements of this set, but you check that suppose this element I need to write, but this is already listed, no need to write it again. Now I need to write this element. This element is also already listed, no need to write it again. So this element is not yet listed here. So I'll write that singleton set 3 and singleton set 1, 3. Okay. Now what I got here? I got P of A union P of B. As we have sets A and B, I can write A union B. So you try to calculate A union B. How to write A union B? First you write all the elements of set A. 1, 2. Now you write all the elements of set B. Now I need to write 1, but 1 is already listed in A union B. So no need to write. Now I need to write 3. 3 is not listed here. So A union B is 1, 2, 3. Now I need to write P of A union B. P of A union B means power set of A union B. The set of all the subsets of A union B. So we know that empty set is subset of every set. First I'll write that. And singleton set 1 is there in P of A union B. Singleton set 2 is there in P of A union B. Singleton set 3 is there in P of A union B. And 2 element subsets for set A union B. What I am doing, I am writing all the subsets of this set. Okay. 1, 2. Next 1, 3. Next 2, 3. Next 1, 2, 3. How many subsets we will get for this set? This set contains 3 elements. Na? Number of subsets is 2 power 3. 2 power 3 means 8. You observe 1, 2, 3, 4, 5, 6, 7, 8. I written all the subsets of A union B. So now I have P of A union B also. Now you observe this 1 and 2. You take this as 1. P of A union P of B and P of A union B as 2. Are these two sets are equal? You can easily understand that in P of A union B this element is there. That element is not in this set. So from 1 and 2 we can easily say that from 1 and 2 what they are saying, is it true? Is it true that P of A union P of B equal to P of A union B? No, this is not true. This is false. From 1 and 2 we can say that P of A union P of B is not equal to P of A union B. So given statement is not true. I hope you understand this. Now we will move to next problem. You observe this question. What they are asking in this question? Show that for any sets A and B, A intersection B union A minus B equal to A and A union B minus A equal to A union B. I don't want to confuse you by taking an element X in this set and that X belongs to this set. I don't want to do like that. This problem is very easy if you do this problem with the help of Venn diagram. I'll try to do this problem with the help of Venn diagram. Okay. You can observe here total two sets are there, A, B. In the question, A, B, two sets are there. So I'll draw those two sets. This is set A, okay, and set B. This is set B, okay. Total two sets I taken, set A, set B, okay. This is set A, this is set B. I want to prove this result. For that, you please observe A intersection B. Where is A intersection B in this Venn diagram? You see this zone here, the middle part. This is the zone which is A intersection B. This we learn while learning intersection of sets, which part is A intersection B, all those things we learn. This part is A intersection B. You observe where is A minus B. In this Venn diagram, where is A minus B? We know that A minus B means all the elements present in A but not in B. Simply we say that A minus B means only A. So here A minus B part I am marking here. Please observe whatever this pink color one is there. What is this? This is only A. All the elements present in A but not in B. Try to understand this, please. What I am drawing here, that is A minus B. This is A minus B. Okay. Now union of these two things, A intersection B, union A minus B. What is this? Actually, I'll name it as 1 and I'll name it as 2. So what is A minus B union A intersection B? Union, this is not intersection. Here we can easily say that. I'll name here this as 1 and this as 2. This shaded part 1 plus shaded part 2 will gives you what? A intersection B union A minus B. Is it clear? What I written here, is it clear? Union means all the elements present in this set, then it present in its union. It can be understood easily. When I do the union of these two things, I'll get 1 plus 2. And you try to understand one more thing here. This is set A na. Set A is nothing but 1 plus 2. From Venn diagram we can understand. So here I'll write from Venn diagram 1 plus 2 is same as set A also. So what I can conclude here? I can conclude that therefore A intersection B union A minus B equal to A. That's it. I hope you understand. I proved this first bit. Now you observe that I'll prove this second one. A union B minus A equal to A union B. Okay, I'll prove this by using Venn diagram. Okay, so I need to prove this one. A union B minus A equal to A union B. First I'll identify what is A union B. You observe in this diagram which part is A union B. Which part is A union B? You please observe here whatever I am marking this part. This is A union B. We learned this in while learning operations on sets, while learning union of sets definition. I explained clearly over there what is A union B in this Venn diagram. See, whatever this pink color part is there, what is this? This is A union B. This part is A union B. Okay, this full shaded part is A union B. Okay, here one point is A union B is nothing but, I'll name this part so that we can easily identify. This is first part, this is second part, this is third part. Part 1 plus part 2 plus part 3 will gives you what? It will gives you A union B. Now you observe this left hand side part, A union B minus A. A means what? 1 plus 2. Is it clear? A means 1 plus 2. Please observe. A is nothing but 1 plus 2. Clear? Yes, A is nothing but 1 plus 2. What is B minus A? B minus A is nothing but part 3. Please try to understand. B minus A is nothing but part 3. All the elements present in B but not in A. Union means we'll add all these things. Try to understand. So here what I'll write here, A is equal to 1 plus 2. A is 1 plus 2. Okay, B minus A is what? B minus A is third place. Okay, so what I want here, A union B minus A. A union B minus A. A is what? 1 plus 2 plus union. Union means we need to write like this only. So you observe here, you take this as 1. A union B is 1 plus 2 plus 3. A union B minus A is also 1 plus 2 plus 3. So what I can conclude here? I can conclude that A union B minus A equal to A union B. This is the easy way of proving this problem, question number 8, with the help of Venn diagrams. I don't want to confuse you by saying x belongs to so and so set and x belongs to another set. One set is subset of another set. It is little confusing to many students. So as they are asking to show that, so I shown this with the help of Venn diagram. Ninth problem also I will follow the same procedure. You see this ninth problem, what they are asking in the ninth problem, show that these two sets are equal. These two sets are equal. I just want to prove this with the help of Venn diagram. I want to prove these things with the help of Venn diagram. Okay. You observe here left hand side part, A union A intersection B. A means here what is set A? Here best thing is I will give the names. This is 1, this is 2. 1 plus 2. 1 plus 2 is set A. Correct? What is A intersection B? You observe this part is there na? This part is A intersection B. So second part is A intersection B. You please observe here what is set A? Set A is first part plus second part. Okay. What is A intersection B? A intersection B means second part. Right. So when we do union A intersection B is what? Is 1 plus 2. It can be understood easily from the Venn diagram. So here you please observe, you take this as 1 and you take this as 2. You observe set A is 1 plus 2 and A union A intersection B is also 1 plus 2. So what I can conclude here? I can conclude that A union A intersection B, which is same as A, it can be understood very easily with the help of Venn diagram. I hope you are understanding. Now second bit, A intersection A union B. We need to prove this. A intersection A union B. Okay. First A. What is set A? Here I will write set A is nothing but 1 plus 2. Correct? Set A is nothing but 1 plus 2. Please try to understand. This whole thing is set A. Na? This whole thing is set A. Na? Set A is nothing but this 1 plus 2. Okay. Now you come to left hand side part. A intersection A union B. Okay. So where is A union B? Here intersection. Intersection means common part. Try to understand what is A union B. Here I will write A union B is nothing but part 1 plus part 2 plus part 3. I hope you are understanding. This part plus this part plus this part. That is A union B. Now A intersection A union B. That means the part which is common in A as well as A union B. What is A? A is 1 plus 2 only. What is A? A is 1 plus 2. I want to do intersection of these two, right? A intersection A union B. In these two sets, in this set part 1, part 2, part 3, set A is 1 plus 2. What is the common part in both? 1 plus 2. 1 plus 2. I hope you are understanding. 1 plus 2 is nothing but set A. So what I can say? I can say that A intersection A union B equal to A. A intersection A union B equal to A. Hence we proved it. I hope you understand. 8th question, 9th question. Understanding with the help of Venn diagram is very easy. Now move to 10th question. You observe this 10th question. What they are asking? Show that A intersection B equal to A intersection C need not implies that B equal to C. I will try to show this with a counter example. So here I will take 3 sets ABC like this. I will take set A like this. A equal to 1, B equal to 1 comma 2 and set C equal to 1 comma 2 comma 3. I taken like this. Okay. Here you observe what is A intersection B. First you write set A and intersection set B 1, 2. You identify the common elements in both. What are the common elements in both? That is 1. So what you will get when you do A intersection B? You will get singleton set 1. Now you calculate A intersection C. A intersection C. What is set A? 1. Intersection. What is set C? 1, 2, 3. What are the common elements you identify? 1 is the common element in both. So A intersection C is what? Singleton set 1. Now you observe here A intersection B, A intersection C, both are same in this example. But here it need not implies that B equal to C. You see that the sets B and C are not equal. So what I can say here, therefore A intersection B equal to A intersection C. Therefore A intersection B equal to A intersection C need not imply B equal to C. I hope you understand this. You observe this 11th question. What they are asking, A and B are two sets. They given that A and B are two sets. And if A intersection X equal to B intersection X and both are equal to empty set, and A union X equal to B union X for some set X, show that A equal to B. Here some data already given. We proved these things with the help of Venn diagram in question number 8. A intersection A union X equal to A. The set B is nothing but B intersection B union X. These things we can understood very easily with the help of Venn diagram. Okay, right. So we need to solve this problem. First I'll write the given data. What is the given data? A intersection X equal to B intersection X equal to null set. A union X equal to B union X. This information they given in the question. Okay. Now I need to prove that set A equal to B. So what I'll do here, I'll use this given data. In the hint they given A can be written as A intersection A union X. So I'll write that one. A can be written as A intersection A union X. Okay. This equal to A intersection. You observe here A union X is same as B union X they given. In the question only they given that A union X is same as B union X. In place of A union X, I can write B union X. Correct? Okay. Now distributive law. From distributive law, this can be written like this. A intersection B union A intersection X. Okay. So A intersection B union A intersection X. You observe in the question they given that A intersection X is null set. A intersection X is null set. So in place of A intersection X, we can write null set. So A intersection B union null set. Here you need to know one point. When A is subset of B, here all the elements present in A are present in B. When A is subset of B, here A is smaller set, B is bigger set. So when we identify A is subset of B, then A union B always gives the bigger set, A intersection B always gives the smaller set. So these things we already discussed in earlier problems also. When A is subset of B, A union B is B, A intersection B is A. Here empty set is subset of A intersection B because empty set is subset of every set, right? When empty set is subset of A intersection B, A intersection B union null set is what? Bigger set you will get. That is nothing but A intersection B. So here what you will get, this is nothing but A intersection B. So I got A equal to A intersection B. I'll take it as equation 1. Now I'll use this data. What they given? B equal to B intersection B union X. This is what they given. Now this equal to B intersection. Here B union X is there. Na? You observe B union X is same as A union X. In the question they given that B union X is same as A union X. So in place of B union X, I'll write A union X. So in place of B union X, you write A union X. Okay, that equal to, this can be written as B intersection A union B intersection X. Okay. B intersection A. B intersection A union. What is B intersection X? In the question only they given that B intersection X is null set. B intersection X is null set. So in place of B intersection X, I can write null set. You can observe here, null set is a subset of B intersection A, and we are doing union of these two sets. So obviously bigger set you will get, that is nothing but B intersection A. We know that in properties of intersection of sets, A intersection B is same as B intersection A. A intersection B is same as B intersection A. So what I got here, B equal to A intersection B. You observe what is the first one? First one is A intersection B equal to A. What is the second one? A intersection B equal to B. From these two things, we can easily say that the sets A and B are equal. Therefore, from 1 and 2, what I can say? 1 and 2, I can say that the set A equal to set B. I hope you understand this solution.